You can say it, it's not going to hurt my feelings. I got to make sure here that Pandora's closed out. Yep, it is. Okay, gang, here we go. Guys, again, the goal, look at using the law of sines to solve triangles. Find all three angles and determine the sides right here. But the part that's going to be kind of difficult today is to determine how many triangles can be made up, okay? We're going to start looking at situations where some of the information that's given might form a triangle. It might form multiple triangles, or it may not form a triangle at all. All right, so first things first, law of sines. Guys, we've kind of talked about the way triangles are set up here. And I think the thing that's most important that we need to understand is this. When we start talking about triangles, we're going to hear me say an awful lot of stuff about a triangle and its side. So for instance, we've looked at a lot of triangles that have been labeled with the vertices A, B, C. All right? So when I start talking about an angle and its side, do you know an angle and its side? Well, guys, I'm just going to kind of go around here with the lowercase letters and label these. The hypotenuse, what would this hypotenuse get? Small b, right? Okay? So when I say here's the angle and its side right here, the b's go together. So really I'm talking about the angle on the side that is opposite here, right? Okay? What's this side going to get? Small a. What's the bottom side going to get for us? So when I say an angle on its side, I'm really talking about the opposite side to the angle. You guys okay with that? Okay, so here's what the law of sines says. Law of sines says this. It says your length A over the sine of its angle, which is going to be the sine of which letter? Well, A. That is equal to length B over, anybody got a guess?
B. C.
Sine of
B.
capital B, which is going to also equal small c over the sine of capital C. All right? Okay, I want to do something real quickly. I want you guys to pull your calculator out. And I want you to understand something. First of all, what's this law about? Law of sines, right? So what function, what trig function are you going to be using all the time here? Tangent function, right? No, we're going to be using the sine function. Do this for me. Somebody punch in the sine of, let's just go sine of 60. Do you guys get 0.8660 for that?
Yeah.
Sine?
60?
Sine of 60. Do you get 0.8660?
Yeah.
Square root of 3 over 2.
Ooh, you got a nice calculator. Divide that out. Square root of 3 divided by 2.
You're staring at me.
Oh, you have the same calculator as me?
Oh, yeah.
0.8660?
No, hold on.
Well, anyway, did you guys all get 0.8660 for that?
Yeah.
Type in the sine of 120 for me. 0.8660, right? What's true about the sine of 60 and the sine of 120?
It's the same.
I have a question. Could 60 degrees be an angle in a triangle? Could 120 be an angle in a triangle? It could, couldn't it? Because all three angles have to add up to how many degrees in a triangle? 180. The point I'm going to make is this. $60 degrees might have been like this, in which case we said the sine distance was 0.8660. Or we had 120 degrees going around to here, in which case, again, the sine was what value? Okay. There are times when you could have two different angles that get you the same sine value. And this is a situation that I'm going to talk about here in a second that allows us to maybe have 0 triangles, 1 triangle, or in this case, how many sine values? How many angles do I have up there that got me the same sine value? 2 of them. You'll understand what that means, but do you understand that I'm getting 2 triangles because the sine of 120 and the sine of 60, both possible angles in a triangle, are both 0.8660? You guys okay with that? Okay, let's get to the heart of the matter here then. This is the big rule. Now what I want you to understand is how many parts are there to this formula? 3. you're only going to use 2 of the 3 at a time, all right? So you might use B with C, you might use A with B, you might use A with C, or so on, okay? But let's just jump right into this and see if we can't figure this thing out, okay? Example 1, I'm going to tell you right here, is going to have 1 solution, okay? And then we'll start looking at situations where it could be no solution, 1 solution, or multiple solutions. So let's talk. Example 1 says, use the law of sines to solve the following triangle. First of all, I like to make a sketch of this triangle. Don't necessarily need to, but I'm going to do it anyway. Here's a triangle. I don't know what it looks like. I don't care what it looks like. There it is. Okay. I'm going to put C down here. I'm going to put my B up here. And I'm going to put A up here. All right, guys. First of all, what information is given? What do we know?
Big A, big B, and little C.
Big A, big B, and
We
little
know
C.
big
So we could find big C, right?
yeah.
Let me just fill in what we know first. 32.2 degrees here. This is 57.7 degrees. Okay, and then the distance that I know is side C, 16.8 is the distance. All right, could you find the distance for C? Or I'm sorry, the angle measure for C,
Yeah.
okay? Where's my calculator? Here we go. Would you guys agree to take 180 minus the 2 angles? That would get you your third angle. So minus, what do we got, 32.2 and what else?
57.7. It's 89.
57.7?
Yep.
What do we get there for an angle? Pretty close to 90, but is it exactly 90?
No.
Guys, is this a right triangle or not?
No.
Not a right triangle anymore, okay? So I'm going to go ahead and call C 90.1. Now, I want to do something. You don't necessarily need to write this down, okay? We need to find little a, we need to find little c. Little b, good, thanks. Okay, we need to find those two. I'm going to go back to what we know about right triangle. Whoa, wait a minute. Can I use sine, cosine, and tangent right off the bat now? Why not?
Because it's not right.
That's only going to work with a right triangle, right? Thank you, Courtney. That's only going to work with a right triangle. We don't have that situation anymore, do we? We don't have that situation anymore. So here's what we need to look at doing here, guys. We need to start looking at law of sines. So I'm going to do the following here, guys. Let's find side A first. I'm going to kind of zoom up on this and make some room for me to write. But side A. Let's see. Can't use the original stuff that we had because it's not a right triangle. Really close, but not exactly 90. So I'm going to use my new formula, which says A over the sine of A equals B over sine of B, which equals C over sine of C. So here's a question for you. Which of the 3 variables, A, B, or C, do you know the angle for and its side? C. We know C, right? Okay. C is 90.1 and its side is 16.8. So let's find A first. Here's what I'm going to do. I'm going to say the length of A is to the sine of angle A. All right? A is to the sine of angle A. So here's the question I'm going to ask. Do we know what angle A is?
Yeah.
What is it? 32 point what? So I'm going to put the sine of what down here? Okay? Then, we want to set this equal. We want to set this equal to the side and the angle that we know that match each other. So the little c that I have here, right here, what's that distance going to be for little c? 16.8 over sine of 90.1. Now, I don't know how comfortable you guys are punching stuff in your calculator. But if you would just cross multiply and divide like this, if you would go sine and make sure that these values that are in a sine function like this are in parentheses, you'll be able to get it. If you go sine parentheses 32.2 times 16.8 divided by sine in parentheses 90.1, you will get an A value. How much is it again?
8.95.
8.95. You guys double check, see if we agree. How many are saying, yeah, that's what I got too? Are we good to go there? I know I'm going quickly, but does this make sense? Good? All right, so we think A is what value?
8.95.
All right. A is 8.95. Okay. Well, let's use this idea then to find our length of B. How about the length of B? What would you set up there? Well, side B is what I'm trying to find. B is to the sine of what angle, guys? Slide it up here a bit. Small b down here corresponds to big B, but do you know the measure of big B? 57 point what? That ratio is going to equal, okay, which side and angle did we know again? Could do Pythagorean theorem. More work. I would say it is. I don't know. That's just me. I'm weird. My crazy Uncle Bill says I'm from north of Highway 3 originally. Which
Limit equal. Well, you could use A or C, right?
could use A or C now, couldn't I? I'm going to use C again. 16.8 over sine of what? Again, make sure you put parentheses around your angles and you'll get an answer for B. By the way, isn't C kind of like opposite an almost right angle? Isn't this almost a right angle down here at C? So isn't this almost a hypotenuse right here? So won't 16.8 be the longest side in this triangle? Both my answers better be less than what then? 16.8. What do you guys get when you punch that mess in? How much again? 10.27. You guys concur? Yes, no, yes? Okay. 10.27. All right, so B is. Okay, so my first concern about this, whoa, that looks like an alligator.
Wait, I just got 14.2.
Yeah, I got 14.2.
Ruh-roh, Raggy.
What did I do?
I don't know.
I just like redid it and I was like,
Wait, is that 57.7?
Yeah.
Oops, I thought it was 37.7. My bad, guys. My bad.
So what's the answer here?
14.2.
14.2. Okay.
Yeah,
That's all right.
I looked and I was like,
that's definitely a 5.
What did you put in?
I put 37.7.
Oh, okay. All right, so that would make sense. How come nobody else spoke up so?
Yeah, nobody
I
raised their
kind
hand.
of just like said yes.
They just wanted to watch you. They just wanted to watch you
Yeah,
struggle.
Jack's like, yeah, that's it. Yeah.
This Jay sticking it in him.
Like what?
He's not dead yet.
You guys got embarrassed me.
You guys know Johnny Aschenbrenner, right?
Yeah.
Yeah, he's funny.
We were talking about stuff in math today. I was like, well, let me show you how to do this the easier way. And you know what he said to me? He's like, go ahead, it's your funeral. So, I didn't have a comeback for that. I was like, whew, that's a good one, John.
I was looking at the ball and he said, hey, Deja.
Yesterday he called
Yeah.
Mariah Bond Deja.
Yeah, but
Uh-oh.
like,
All right. Guys, big rule right here. Yeah, first of all, you understand how to apply the formula, number one. You understand how to apply the formula, number one?
Yeah.
Okay, number two then. Right down here it says, we can use a law of sines on any triangle if we know a couple things. It says if you know a side and it's what? Okay, as long as you know a side and an angle, like an angle on the opposite side, and then it says along with anything else, another angle or another side, you can use this. All right? So if you know an angle and its side and anything else, you can use this. Make sense? Okay. So, let's get into this stuff, and I hate to tell you this, but this is the part where things get pretty difficult. it says for the information given in some triangles will allow us to form, what did we say in the beginning? You might have a situation where the information they give you doesn't even make a triangle. You might have a situation where you have just one triangle, or you might have enough information there to form two triangles. Okay? Now, rules for the number of triangles. Jackie, you remember doing this?
Yeah, we addressed it just, didn't we?
A while ago, yeah, but we had a chart kind of like this, didn't we?
I hated it.
It hated it. All right, well, it's back again, and it's not going away. Guys, this part right here, big time, big time, big time, big time important, all right? And I just want to go ahead and double check and make sure I typed up everything correctly in this, but this is way, way important. Okay? First things first. It talks about a case 1 up there, and it says in case 1, I might have screwed this up. And that's okay. Okay, case 1 talks about this idea of measure of angle A is less than what here? 90 degrees. Now it's possible A might be more than 90. We agree there? Everybody agree? It's possible A might be more than 90? Yeah. Okay, so in example 2 right here, here's what I want to start doing. Okay. I'll make some room for case 2 here in a second, but in example 2, here's the deal. It says solve the triangle ABC if angle A is how many degrees? First of all, 38 degrees. Okay. Does this fit this idea that this angle A is less than 90 degrees right here? You guys okay with that? All right. So here we know that B is 10 and side A is 8. First things first, do we have an angle and its side? What's the angle?
A.
Which is how many degrees? And what's the side that goes with it? The 8, right? Okay, so we have an angle on the side. Do we have something else?
Yep.
Okay, so this says then the following. It says, you know what? You can use the law of sines. Now, the question becomes this. How many triangles can I form? Okay? Question becomes this. How many triangles can I form? Case 1, A is less than 90. We've satisfied that. Here's 4 different scenarios right here that tell you how many solutions you're going to have over here. First things first, it says A is equal to what? B times the sine of A. If that was true, how many solutions would you have? According to that rule, 1 solution, right? Oh, let's see. A is less than what? Well, it says B sine of A, doesn't it? Then what would happen here? No solution. This one here says A is greater than what? B times the sine of A. Also, A is greater than or equal to what? B. What's it mean? And here's another mess. B times the sine of A is less than A is less than B. What's that mean? 2 solutions. Okay, here's the deal. In all 3 of these problems, we're comparing a small distance A to B times the sine of A, right? Would you agree with that? Okay, so here's how you handle this. Anytime you're working with these right here, first of all, write down your A value. What is your A value? 8. I'm going to write down my B value. I'm even going to write my B value down. What's B equal to? 10. Okay? Now, I think an important part would be this. Every time in these problems we compare A to a B times the what? B times the sine of A. So somebody do this for me. Write down what B sine of A is equal to.
6.1.
Okay. What we would do is we would do the sine of 38 degrees times the B value, which is 10, right? Okay, so just to see that again, what did you say it was, Jackie?
6.1.
6.1. I'm going to confirm that real quickly. B sine of A would be the sine of 38 times the B value of 10, right? So on my calculator, I'm going to go 38 degrees. I'm going to sine this out.
Or it'd be 6.2.
I'm just going to times that by 10, all right? So 6 point how much?
2.
About 6.2, all right? Everybody agree that that's about 6.2, that value that we're going to kind of compare, figure out how many triangles there are? So this is equal to 6.2. All right, let's make some comparisons. Does my A value equal B sine of A right here, first of all? Are these equal? No, so I can rule this one out. This one's not going to work, is it? I'm going to put an X up there. Say, nah, that's not going to work. All right, how about this? Is A less than the sine, or I'm sorry, B times the sine of A? Is my A value less than that? No, so is the next one going to work? No, that's not going to work.
Wait, okay. Can you go through the why B sine A doesn't?
The first one?
Yeah, I didn't catch that.
Okay, what's my A value here?
8.
So this is like 8 equals
Oh, okay.
that number. Is that true or false? False, so that's not going to work there, right?
Right.
Okay, and then the second one, is this 8 less than that mess? No. Okay, that's not going to. How about the next one? Is A greater than this right here? Ah, that works, right? And is A greater than or equal to B? Works here, we're good here, but is this A value bigger than B? Do I satisfy the second condition for this one rule right here? I don't, so that's not going to work. No, not going to work. Which one's looking like it might work for us? The last one. Okay, is B sine of A. This is like the 6.2 value right here, right? Is that less than my A value, which is 8? Is that working? And is that 8 less than the B value of 10? Is that working? You guys agree with that? Okay. We're probably going to get through this example here today and probably end here today, but that's okay. But how many triangles look like are here that we can form with this given information? There are going to be 2 of them. Okay, so here's what I want you to do. This information, since this is true, I'm going to write down since 6.2 is less than 8, is less than 10 in this, according to these rules up here, we are going to have 2 solutions. All right, so let's see if we can't solve those 2 triangles right here. You understand how to read this chart right here? Okay, now keep in mind, this is just case 1, in the case where angle A is less than what? Less than 90. Case 2 is much easier. That's the case where we're going to be more than 90. All right, Jaden, question?
Okay, so for the one that it's working on, A has to be smaller than B
Yes.
for it to work.
Yes. These are basically the same thing right here. It's just switching it around. This is saying A is greater than B, and this is saying A is really less than B, right? Okay with that? Okay, so it's pretty much the same thing. I could have done it this way where, if you didn't like this the way it is, I could have said, you know what, cross this out, and then call this A less than B like that. Is A also less than B? We could have done it that way as well, okay? Either way would work there, all right? Okay. Okay, so let's find these 2 solutions. Let's solve this, all right? All right, here we go. First of all, in these 2 triangles, I want to write down what I know. So I'm going to go ahead and say solution 1 right here. Okay, put my angles here. Angle A, angle B, angle C. Little a, little b, little c. All right, tell me what we already know. Little b is 10. Side A. Okay, so the question is this. You told me that, or I guess I'm answering the question for you, but you guys told me that the angle and the side that we knew was for A, right?
Yeah.
So I have to use them somehow, okay? What's the other part that I know then? We know what B is here, right? Okay, I'm gonna try and squeeze some work in over here. First thing I'm gonna choose to do is try and solve for angle B, okay guys? Try and solve for angle B. So here we go. Would you guys agree that B, which is 10, the sine of, do I know what angle B is, guys? Measure-wise?
No.
No, so I just have to put in the variable capital B. That would equal, all right, hear me out on this. That would equal my A value, 8 over what?
Sine of 38.
Put this over here a little bit. Sine of how much again?
38.
Yep. 8 over the sine of 38, right? Okay, here's what I want you to do. First of all, 38, you want to make sure you put in what? Parentheses. Now, am I solving for B or am I just solving for the sine of B here, guys? Sine of B. So here's what I want you to do. Go 10 times the sine of 38. Or you might want to go sine of 38 times 10 divided by 8 when you do that. Make sure we get a couple people to agree on the value first of all. How much? 0.7? 7696. Are we getting 0.7696 out there? Anybody not getting that? Okay, so this implies right here that the sine of angle B is equal to 0.7696. All right, how could I use that information right there to solve for angle B?
Inverse of sine.
Inverse the sine, right? Do the sine inverse of that decimal, 0.7696. So I'm going to say angle B is equal to
50.32.
sine inverse of 0.7696. And you said 50 point what? 50.32. Okay, 50.32 degrees. Awesome. Put a star by angle B because this is going to be really important. 50.32 degrees, right, guys? Remember that idea about the sine of 60 degrees and the sine of 120 degrees at the very beginning? Okay. What does 60 and 120 add up to? 180. Okay. Anybody got a guess what the other angle B might be in the second solution, estimate-wise?
130.
130. Who said 130? Jackie, why do you think 130?
Because it would add up to like 180.
Yeah, here's the deal. If I go 50 degrees, here's the deal. Guys, isn't the sine function the distance above the x-axis? Isn't the sine function the distance above the x-axis? Okay, so if I go 50 degrees this way or 50 degrees over here, aren't you still at the same height? Okay, let me draw it. So you're looking at me like, what are you talking about, Chumzilla? All right, no problem. If I go 50 degrees this way or 50 degrees this way, aren't we the same height above the x-axis? You guys agree? But this angle is 50 measured from the x-axis. What's this angle right over here going from here all the way around? How many degrees would that be? 130, wouldn't it? Okay. So I'll show you how to get that other angle, but just keep that first angle that you found in mind because we said how many solutions to this triangle? 2. All right. So here we are. Guys, do I have enough information to solve for side C now? What's the angle down here?
91.7.
91.7. Add these two up and subtract it from 180, right? So 91.7 you say? 91.68, depending on how you round. I don't care. Do we understand how I got that angle right there? Yes? No? Yes? All right, so do I have enough information to solve for side C now? Well, here we go. I could say the side C over the sine of how many degrees now? Equals, let's use the first one we were given. We knew the A's, right? We knew the A's. That would be 8 over what here? Sine of 38. Hey, quick question. Do I need to do any inverting to find an angle here or not? No. We have both the angles, right? So in your calculator, go sine of 91.68 times 8. Divide by sine of 38. And you will have side C, and you'll have one solution of the two. What you got, kiddos?
13.
13-ish? 13 on the dot, close to 13? I'd buy that. I'd buy that. Gosh darn problem here, as we said, there was how many solutions. Well, guess what? You're almost done.
Do the small ones stay the same?
No.
Do the angles stay the same?
Couple of the angles will stay the same. One angle will stay the same. It's the one that you know. And I'm going to draw these out here after we get these figured out and show you how this works here in a little bit, okay? But solution number 2 here, put back in what was given. You have to put back in what was given. So angle A was how many degrees, guys? 38. Side A was 8. Side B was 10, right? Those were your givens. All right. Remember that B I said put a star by, that first angle we said put a star by? Remember that? Here's how you find that. If you ever have two solutions, take your first answer and subtract it from 180. So in your calculator, go 180 minus what value? 50.32. What is that? How much? 129.68. Okay. My rule for the second solution was that first angle that you found, subtract it from 180. Okay? So I took the 50.32 from 180. This only works when you have how many solutions? 2. Oh, hey, doesn't that help you find angle C right off the bat here?
88.32.
How much again?
88.32.
88.32 seems high. I would have to add these two together and then subtract from 180, right?
Oh, okay.
It's going to be pretty low. 12.32 degrees? I agree. 12.32 degrees. What's the last thing we have to find here? Side C. Now I'm kind of out of room here. Again, these all three add up to 180. I'll put the rest of my work over on the side here. But to find side C in solution 2, I would say small c. Hey, watch it. Do you want to go? All right. All right. Side C over the sine of how many degrees? What do we have here for angle C now? Yep. Side C over the sine of 12.32. That's going to equal my, let's go back to the ones we knew to begin with. Length of 8 over what, gang? Length of 8 over the sine of, yeah. It should be shorter than both, I think.
Yeah, it's 2.7.
2.7-ish.
Yeah.
We agree?
Maybe 2.8.
2.8? Okay, so my C value here is about 2.8. So what I want to get at is this here, guys. Given the conditions here, and there's a lot of stuff going on here, and I think I'm going to end right there today. But given this information right here, these stayed the same, didn't they? The A's and the B's. These all stayed the same over here, didn't they? If you had those given conditions, how many triangles could I form? Well, 2 different ones with these measures here for angle B, angle C, and side C, or these measures here for angle B, angle C, and side C. All right? A lot of stuff going on here. Don't panic on it if you don't get it, okay? I guarantee you I'm moving this book page back to Tuesday already, all right? Not Monday, but Tuesday at noon. So if you start looking at it, great. I still need to look at case 2, where that second angle is not less than 90, but more than 90 first thing tomorrow, okay? Guys, what questions have you got for me?
questions? None at all? All right. Very good. You guys enjoy